Okay, so in the last class, we have specifically discussed about the factory pattern and then the singleton pattern, right? So, so we saw two different design patterns, and the reason for discussing these design patterns are uh, just to give you an idea of what all different design patterns we have out there, and Spring actually solves one of the design problem. Okay, so yeah, today we'll get started with the Spring. Okay, before we start on the Spring, any questions on the earlier topics? Okay, can someone quickly summarize what is singleton design pattern? So basically ensuring just only one single object of a class is present in the JVM is called singleton pattern, right? So so we restrict the object creation, right? So we don't simply allow the other classes to create the object easily. Instead of that, we ensure that only one single object is present across the application. Okay, so quick question. So is it suitable for our calculator example, right? So we saw that yesterday it is more suitable for calculator because it doesn't have any state and the same one can be applicable across. But tell me, can we use an object like student? Can we make an object like student a singleton? So I have a student class. It has name, enrollment ID, address, and city. Is it suitable for the singleton pattern? Can I make my student class as a singleton? No. Okay, Thomas, do you care to explain why singleton is not actually suitable for student, but it is suitable for calculator? Okay. So the reason is because we saw some okay. So the main reason is it's not just because it has some we pass something to the parameters in the constructor. So the reason is if you look at the calculator class, right? So if you go to the calculator class, if you take a look at our calculator class, even if you create 100 different objects, so this is our calculator class, right? So even if you create 100 different objects, they are all the same, right? So all even the 100 calculator objects, they represent the same. It's simply that they have 4 different methods they have, right? Because it is a stateless thing, right? So there is no difference between different calculator objects. But when it comes to something like student, it is a lot different, right? So it's not a stateless class, it is a stateful class. Okay, so for suppose if I create an object of student s1 and s2, okay, s1 might be having enrollment id 1 John, right? S2 might be enrollment ID 2, and then he might be Chris or something, right? So is there any difference between these two objects, right? So they have a state, and that state makes them unique, right? So singleton is suitable when you do when the class is a stateless class. Okay, in scenarios like this, when the class is stateless, only one single object can be used across the application. There is no need for multiple objects. But in when the class is stateful, like the student, right? If you have 100 student, you need 100 different student objects, and all of them are different from each other. Okay, so Yeah, to reiterate, singleton pattern ensures that we only have one single object of it created across the JVM. Okay. 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 Can someone tell how do you make a class as a singleton class? You need three things for it. Anyone? What's the first step? Okay, so the first step is private constructor. That way, you don't you restrict the object creation outside the class, right? And the second thing is having a static method and a static variable. Okay, so that way you'll have one object for per a class, and you'll have a static method which can be called from anywhere to get the static variable. Right. Okay. So coming to the factory pattern, okay, factory pattern is another creational design pattern that's widely used, but this is useful in scenario of having a parent class and having multiple subclasses to it. Okay. So the main purpose is, if you see, so the main purpose is we can code for the interface rather than subclass. Okay. What does that actually mean? What does coding for an interface actually mean? Okay, so let's go to our okay. So so factory pattern is where you ask for the kind of object that you need. Okay, so you don't create the object on your own, right? But you ask for the object of your need. Once again. Okay, so you simply say, I want get instance of type this. Okay, whatever that might be changing during the runtime. So you will ask, I want this type of object, and the factory will make sure that that gives you the right object. And now you can code according to your interface. Okay, right? Everything below that is strictly according to the interface, because on this object you can only do things that an interface, I mean the parent interface can do. Okay, so the factory pattern is more suitable in parent and child scenario, and it takes the responsibility of the object creation, right? So the benefit you get is, if you don't have a factory pattern, you might do something. Let's get rid of this. Okay, so you might simply hard code a child class here. So if you hard code the child class, everywhere below, you might get the same functionality of the child class, whatever you hard coded here, right? So whatever the type that the user wants, you'll still get one single subclass functionality. Okay, instead of that, if you have a factory, right, and if you simply tell what kind of object that you need to the factory, it it will get the right object here, and right, so you can get different functionalities and you can code according to the interface, right? So that's more about the factory design pattern. Okay, so today we're going to discuss about Spring framework. Okay. Okay, any questions before we start on that? All right, let's get started. Okay, Spring framework, sometimes it is referred as Spring, some people call it Spring framework. Okay, so it doesn't matter if it is Spring, that should be enough. Okay, so basically this is released in almost 2 decades back. So the first Spring is released in 2004. And right from the beginning, it is always an open source framework. Okay, meaning you don't have to pay for it to use this. Okay, so this is always an open source framework, just like Java. So when the Spring initially started, okay, it started to solve a problem called dependency injection. So this is a different design pattern that we'll see in a while, that we'll learn in a while. But when Spring initially started, it started to solve a small problem related to the designs in the Java application. But over the next 20 years, they grew into a lot of projects like the Spring Web, Spring MVC, Spring Data JPA, Spring Boot, and so on. Right now, they have solution for any concept that you take, whether it's databases or whether it is APIs or batch applications. So the Spring guys, they have a solution for each and every problem that we have in the software industry. Okay. So if you look at Spring, so simply type Spring and you can see spring.io. So if you go to the spring.io, that's where you can see all their projects. Okay. So if you simply go to the projects, so these are all the projects that they have. So they have Spring Boot, Spring Framework that we'll discuss. Okay. Spring Data, yeah, which we'll discuss as well. They have Spring Cloud, Spring Security. Okay. So if it is database related thing, we can use Spring Data, which is even a lot better than the Hibernate. Okay. So you learn JDBC, you learn then Hibernate, and then there is even better things like Spring Data. So you can use Spring Data instead of the Hibernate. So if you want security for your application, you can use Spring Security. Okay. And you have integrations, REST things, you have Spring Batch, and so on. If you're using some asynchronous stuff like Apache Kafka, Spring has a solution for that as well. For web services, they have a solution. So there are many Spring projects that we can use to build our application. Okay. So what does that actually mean for us? So we know that Hibernate is a set of jars. Okay, so if you add the Hibernate dependency, you will get maybe 10 different jars, and your application will get all the Hibernate functionality. Okay, so similarly, Spring, if you look at physically, it's nothing but a set of jars. Okay, it's not a tool that you install on your application, or it's not anything like Java, IntelliJ, or the Maven, nothing like that. It is simply a set of jars that you add to your application. That way you get all that functionality. Okay, so if you remember, we want to build an Hibernate application, right? So you specified a dependency for the Hibernate, and you started writing code in terms of session factories, sessions, transactions, and all that stuff. So similarly, if you have a plain application, if you want to make this as a Spring application, then you need to get the Spring jars. Okay, so they provide their functionality in terms of jars. If you add those jars to your application, then it's not just application, it is now a Spring application. Okay, and now we learn what all classes this provides, right? So when you're learning Hibernate, all that means is you're learning the classes that are in these jars. So you learned about the session factory, you learned about session, you learned about transaction, right? And all that. So simply learning a framework simply means you study those jars and you learn about what classes we have in those jars and how do they, what functionality they give us. And the same here. So for the next few days, we're going to learn about the Spring. That means simply two things. We'll add the Spring dependency in our application, and we'll simply use the classes that we have in these jars. Okay. Okay. Any questions on that? All right. Okay. So when the Spring initially started, right? So it started to resolve a problem called dependency injection. Okay. So that is this one, the Spring framework that you see, right? So if you just look at the overall view, it provides support for dependency injection, transaction management, and all that stuff. Okay. So this is the one that they initially came up with to solve the dependency injection. Okay. So before that, before we see what is spring and how it is solving, so we should understand what is dependency injection. Okay, so let's spend some time to understand what is dependency injection, and then we can see how the spring is solving that for us. Okay, all right. So let's get started. I'll give you a scenario, and then let's start with the scenario, and then we can do more. Okay, so I wanted to build an application, some automobile application, right? So that has cars, wheels, engines, and all that stuff. Okay, so I want to, I have a class called car. Okay, and what it should do is it should move. Okay, so it should, three things. It should move, uh it should halt, okay, and so on. Okay, so a car should be able to do all these things. Okay, so but for the car to function properly, it needs, okay, I have a different called tire. Okay, so which actually has the functionality to move. Okay, so the tire is the one that will start moving. Okay, so we're just mimicking a real world thing. So I have the class called tire. Okay, so which does all the moving, so it will take care of rotating the wheels and all that stuff. Okay, so now my car needs the tire functionality, right? So it needs a tire to function as a car, right? So how can I use the tire functionality in the car? What exactly do I need to get the tire functionality in the car? Call tire. So what do you mean by calling the tire? Okay, so yeah, so I should ultimately call the tire method to get the tire behavior. But how do I call the tire? How can I call the tire method to get the movement in the car? What do I need to call the methods of the tire? So it simply means calling the methods of the tire gets you to the tire behavior in the car. But how can I call the tire methods? Right. You need an instance, you need an object of the tire, right? So for that, you will do something like tire t equal to new tire. And now your car can actually move, right? So if you have a main method, the main class with public static void main. So now if you create a car object, and now your car can move proper, right? So it got all the functionality of tire movement, right? So and now you can see that the tire is moving. So right, so here the car is dependent on the tire object, right? So you have a car, but for it to perform properly, you need a tire object, right? So you need an object to actually get the functionality. So same thing. So when class A uses some functionality of class B, it is said that class A has dependency of class B. So here our car has dependency on tire. It's not the Maven dependency. Okay, it's just the dependency in Java terms. Okay, so the car to function properly, it needed a tire object, right? So we see so it simply means that it simply has to create an object of the dependency. So before we use the methods of another class, we first need to create the object of the class. So class A needs to create an object, an instance of class B. So for that purpose, just like you said, car needed instance of tire, right? So it needed the instance of a tire. So we created the instance of the tire. So that's it. So if one class needs the functionality of another class, that simply means it needs the object of the other class. Okay. So in this scenario, right? So you needed a tire. So you simply hard coded the tire. You created the tire using the new keyword. Okay. So what if you have a different tire? Okay. So you have a better tire that extends a tire. So assume this is even better tire that can move on off-road. Okay. So now what do you do if your car needs the off-road behavior? Okay. So we have a better tire, and for that one, you need a better tire, not just a tire. It needs the functionality of this better tire. So this better tire can actually go on off roads, right? It doesn't have to go on a road. It can even go on the off road. So now the car needs the functionality of this. What do we do? How can the car get the functionality of the better tire? You'll simply make something like this, right? You simply replace the tire with a better tire, and now anywhere in your application, if you try to, the car functionality will look as the off-road tire, right? So whether you create a car in this test 100 or you create a car in the main, even there, it is the car will have the off-road behavior only because you hard-coded the object creation, right? So the dependency is hard-coded here. So you created the dependency using the new keyword. Okay. So this way you can't actually have different tire functionalities. Every time your car can only perform as a single way. Okay. So instead of that, okay, instead of that, you can use, instead of we creating the new object, okay, using the new keyword, we can ask someone else to provide the object. That is called dependency injection. So here we are creating the object with a new keyword. Because of that, anywhere in your application, you get the same car functionality. So the car will perform like an off-road car, which you might not want across your application, right? So even in your main class or in your test 100 class, the car is performing like an off-road thing, right? So instead of that, instead of you creating the object with a new keyword, okay, so if you ask someone else to give this object, then that is called dependency injection. So let's see how we can actually do. So we needed a tire object, right? So the car to perform, you needed a tire object. Okay, but how do we get the tire object? You can get the tire object maybe through the constructor. Okay, so you can have a constructor that gives you a tire object, and you can say, so during the car creation, they can pass the tire. Okay, so now you're not creating the object using the new keyword here. So you're simply allowing others to inject whatever kind of tire they can give. So now in here, I can give maybe here I can, in my test 100, I want a better tire. Okay, so now here I can inject the better tire. But in my main class, I don't want the better tire. I just want the simple tire. Okay, so now I can inject the simple tire. Okay, so if you run this class, now the car will move like a regular tire. So in the main class, the car is moving like a tire. Okay, but in the other class, the same car object, if you see the functionality, it is okay. 1 second. If you run the this thing, whereas the test 100, whereas the tire is taking the better tire, car is taking the better tire, now you get the off-road tire functionality. Okay, so this is called dependency injection. Okay, so dependency means if one class needs the functionality of another class, it needs that object, right? So instead of you creating the object using the new keyword, we ask someone to provide that object. That is called dependency injection. So now here, who is providing the object? Right? So whoever is creating the car object, they are providing their own tire object. So now here the car functions as a better tire, and in somewhere else in your application, the car functions as the normal tire. Okay, so did you see the benefit of the dependency injection? If you have the dependency injection, you're not hard coding the functionality. You're not restricting your class to have single functionality. It can be anything, right? It can be a regular tire, or it can be different variants of tire. Of course, this has to be, this can only take its child classes. Okay, but the main thing that you should understand here is having the dependency injection allows you to inject whatever kind of subclasses you want. Okay, so if you look at this, right, so this class needs objects A and B. Okay, so it simply says, please give me those. So if you look at the car, this actually means, okay, car is telling that I need a tire object to I need a tire object to perform, right? So give me a tire object while you create me. Okay, so it's a way of telling that I need the tire dependency. Okay, I need the tire instance. I'm dependent on it. So I need the tire dependency. So give me that so I can perform as a car, right? So that's what the dependency injection actually means. So now our car is asking for the tire object, and the dependency injector, or here the client applications, whatever we have, whether the test 100 or this guy here is telling, the main is telling, okay, car needs a tire. So I'm gonna pass this tire while creating car. Okay, so this is the client application. So that recognizes that, okay, car needs a tire functionality. So when I'm gonna pass, so it created a tire object and it's simply passing to the car. So that way now the car moves as an off-road car, I mean with a better tire. Okay, so it's simply creating the object and it gives that to the car, and now car is happy. Okay. Does that make sense for everyone? Is that clear? What is so this is called as dependency injection. Okay. So instead of we creating the dependencies using the new keyword, we ask the client applications to it. So the other way to do it is you don't ask the tire object while creation, and you simply do this, right? So this is hard coding, right? So this way the car will always be tied, is strongly tied to this tire. Yes, go on. Any question, Chunwa? Okay, so if you create the dependency using the new keyword, it is tightly coupled with the car. The car can only function as a tire. But if you leave the room for the dependency injection, you can get any type of tire, any subclass of tire here, and the car functionality simply changes. Okay, so that's what a dependency injection actually means. Okay, any questions on this? Did you all understand what is dependency injection? I can only proceed if you understand this. It doesn't make sense for me to proceed if you don't get this. Any questions? Do you want me to repeat it, or are you good with it? I want you all to respond.
Can you
So
summarize it again?
okay, I mean, what part did you didn't get it?
No,
Okay.
from there.
So I'll just summarize it again. Okay, so many times in your applications, right, one class might be dependent on a different class, right? So here, the car is dependent on the tire, right? So in the many places when you write the applications, it not just one single class can do that everything, right? So one class needs the functionality of another class. So then we say that that class is dependent on the next class, right? So you need an object for it. So you need an object of dependency class so to do your work, right? So the dependency injection actually means this, whatever you see here. So it's simply a constructor that you already know, but so this is not a fancy thing. You're already learning it. Okay. So you might simply code, okay, you thought I might simply need a tire, so I'll simply go for a tire, right? You can do this as well. There is nothing wrong in this, right? So this way, the car is always tightly coupled with the tire, this particular tire class. So it's it has to be the same thing always. But instead of that, if you allow this dependency to be injected, meaning if you leave it open to the classes to inject this dependency, then you can get the different functionalities. Here, someone can pass the better tire, which is the child class of the tire, and here they can pass the normal tire, because in the main class they just want the car to perform as a with a regular tire, but here they want the car to perform with a better tire, right? So if you have the constructor that accepts these dependencies, then that simply means it is the dependency can be injected, right? So instead of we creating the new object using the new key, we ask the dependency injector to provide the object. So now the the car is simply telling that I need a tire object to perform, so give me a tire object. So whoever creates a car, they have to pass this tire object. Only then the car will perform. So that way, the dependency here is the tire is injected here, right? It's not hard coded. So this way, in future, if you have even more better tire, right? So you can inject that. So the car is open for taking any type of subclasses of the tire, and it performs accordingly. Okay. So it's not a fancy thing. You already know what is a constructor. But the thing that you should understand here is the way you write the code, right? So if you write the code this way, it's not a great way to write the code, because car and tire are tightly coupled, right? So the car can only perform as a tire. But if you write the code keeping dependency injection in mind, right? So now this is open for improvement, right? So the tire can be, today it can be a tire, tomorrow it can be a better tire, and later you might even write a better tire class and you can inject that into this class, right? So nothing fancy. It's just that you have to acknowledge that instead of we creating the dependencies with the new keyword, we ask the others to, whoever is creating the car, we ask them to provide the tire. So that way they can come with whatever tire version they want. Okay, so does that make sense, everyone? All right, I'll stop here for some time. Let me know if you understand, and then we can proceed. If you only want to speak in the evaluations, which is also fine with me, but the thing is, I have to really be very strict in the evaluation, because I don't know whoever understood here or who didn't get it, right? So the evaluation has to be so rigorous to understand who actually understood it or not. All right. All right. I hope you all understood. If you are here to learn, you should always ask question. Don't leave the class with any doubts, because the next few things that you see, it will be very quickly escalated, right? So anything that you see after, we just have a 2 weeks of time. But if you see, there are a lot of things to learn, right? If you don't understand anything, then it's hard for you to follow the next things. So if you have a question, raise your question and just let me know. Okay. All right, so that's what a dependency injection means. And Spring, guys, they initially came up with a solution for the dependency injection. Okay, so this dependency injection, so this is a design pattern. Okay, so dependency injection is a design pattern, and this is one way of inversion of control. So this can also be called as one of the inversion of control pattern, right? So it is called as inversion of control because now the control is in client's hand, right? So we are putting the control in on the client class, whoever creating the car, right? So that is the inversion of control. So the control is going from here to here, right? So the control is in the client's hand, so they can inject whatever the kind of object they want. Okay, so that's why dependency injection is also called as inversion of control pattern. Okay, so it's basically about removing the hard-coded dependencies from your code. Okay, so it's all about having this constructor instead of this, right? So this is the wrong way of doing, and this is dependency injection way of doing. Okay. All right. So the Spring guys, when they started in 2004, they came up with a solution, and they told, okay, we'll do the dependency injection for you. Okay, so you don't have to worry about managing the objects in your application. Okay, so just tell us there will be something called Spring Container that will take care of managing all the Java objects for you. Okay, so they came up with the Spring framework. So Spring framework, it ultimately have one simple thing called Spring Container. Okay, and the Spring Container will maintain all the objects. Okay, so it will maintain a car object, it will maintain a tire object. Okay, it will maintain a better tire object, and if the car needs better tire, it will simply inject into it. Or if the car, if you need a different car object with the tire object, it simply injects into it. Okay, so the Spring guys told, okay, you don't have to do the dependency injection using the new keywords. Okay, so we came up with a solution called Spring. We have something called Spring Container or Spring Bean Factory that manages the Java objects, meaning right from the creation to till the death of an object, right? It manages whole the life cycle of the object. Okay. So before that, let's see how we can actually set up a Spring project. So we need the, so what type of project do you want to create? Anyone? So you have a lot of options here. Which type of project do you want to go with? And why? So like I said, ultimately building a Spring application simply means getting the jars and putting the jars in your application. Right? So you simply have to get few jars and you have to put that in your application. Right? So which of that allows us to get the jars here?
Maven.
Right? So we can go for Maven and we can tell dependency injection test. Okay, I'll go for the Maven dependency injection test. I'm fine with Java 17. Okay, I'm not selecting any archetypes. I just want the plain Maven. And let's also with the group ID and artifact ID, I'm okay with the org.example. So okay, I think it has to be. So it's asking for an archetype and we just want the basic archetype here. Okay, so just type this Maven archetype quick start. So that might give us a basic Maven application. Okay. Okay, so that created Maven quick start. That's, let's see what it's going to give. This is not what we wanted. Okay. New project. Okay. Okay, I'll select the Maven from here. Okay, so it's new project Maven and then create. I'm not going to choose any archetype because I just want the plain Java application. Okay, so now I got the basic Maven application, right? So This is a Java application. Now I want to actually have the Spring functionality in this. So we need to know what is the Maven dependency for this Spring. Okay, Maven Spring dependency. Okay, Spring. I'll even type it more. Maven Spring dependency injection. Okay, so the one that you see here, like the Spring context, right? So this is the basic one that gives you support with the dependency injection and all that. Okay, so let's go for the Spring context. Okay, so this is what we need. I'll just copy it and I'll paste it in dependencies and then a dependency. Okay, so now I'll simply reload the Maven. So I'll get these jars. So looks like we got it. So if you see your external libraries, you can see that Spring Core, Spring Context, Spring Beans, Spring AOP, and all this stuff. So all these jars are pulled with this Spring Context thing. Okay, so now we are ready to use Spring in our application. So we can start using the Spring. Okay. So the first thing is, of course, getting the required jars in your application. And the next thing is configuration. Okay. This might all take some time. Okay. So that's how we basically set up a project for the Spring. So now this is a Spring project because you have all the Spring functionality. So tomorrow we'll see how we can actually configure this and how we can actually do the dependency injection using the Spring. Okay. So because there is quite a thing that we should do here. Okay, all right, let's spend 5 more minutes and see if we can cover at least the important stuff. Okay, so that's how you make it a Spring application. And the second thing that you need is configuration. So you should tell Spring, okay, what all classes that it should focus on. Okay, so let's start writing the classes. I'll say I want a car class, and then I want a tire class. Okay, so inside the tire, it knows how to move. Okay, okay, and the car needs the functionality of the tire. So it will have an object of tire. Okay, and it will simply call t dot move. Okay, so that's how the car can achieve the functionality of a movement through the tire. Okay, so now we have car, we have tire. The tire needs so the car needs the tire object to do its job. Okay, so like said, the Spring Bean factory will take care of managing all these classes objects for us. Okay, so for that we need to maintain uh, a file called beans.xml under the resources. So I'll create a file called, so objects is called as, also referred as beans in the Spring world. So if it is beans, that means they are calling it as objects. Okay, so you need some configuration here. So you need to tell the Spring what all things that it should consider. Okay, so for that we simply copy paste this stuff. So this is like the boilerplate stuff for any of the Spring application that you take. Okay, so all this means is we are telling that do the component scan, meaning consider the classes which are under org.example. So we are telling the Spring, okay, whatever the classes are under org.example, consider all those classes. Look at all those classes. So we are simply telling that what package does the Spring has to consider. Okay. So now there are few annotations. So the Spring start looking at all the classes one after the other in this package, but you need to tell more to this uh, classes. Okay, so you have to tell that you have to annotate with something called component. So if it sees this as a component, then Spring will understand, okay, so this is a component, so I need to take care of this class. Okay, and in here you can, okay, so you can simply have a constructor. Okay, and that's it. And in the tire also we want this to be taken care by Spring, so we'll say auto white, sorry, it's component. Okay, so now we told the Spring that consider all the classes under the org.example. Okay, and we also at the class level we told that a few things about the annotations. Okay, we'll discuss what that exactly is. So annotating with the @ component will simply we're simply telling the Spring to consider that. And here comes the important thing. Okay, so if you remember in the Hibernate, so we started by creating the session factory, right? So similarly with the Spring, we start by creating this Spring container, or it can also be called as application context, or it can also be called as bean factory, Spring bean factory. Okay, so we start by creating these application context, right? Okay, so we create the application context and we tell, so we tell where the file is, what's the file name that it should consider to create this application context. So it will create something like this. It will create an application context, but in order to create that, it has to look at the configuration, and the configuration we are telling, okay, so look at this, and here we are telling, look at all the classes under org.example, and in the org.example we have annotated these classes. Now the Spring will create the application context based on looking all of them. So what that actually means is when it will create an application context with an object of tire, with an object of car, and it will inject the tire into the car. Okay, so now, so it has the objects. You told that you want Spring to consider all the classes under org.example, and you also annotated the car and tire. So it will not consider the main because you haven't annotated it. So now the application context has all the beans. So you can now get the beans from here. Bean simply means object. So you can tell that you want car bean. Okay, and now you can say car.move. Okay, so this is very much identical to car C equal to new car. But the thing is, we are not creating this car. We are simply asking the Spring application context to give it. right? So there is only one car object. Now it can give that as, okay. So I'll run this and then you can see how it works. Okay, so you can finally see that here the Spring context gave us a car object, and we called the move method on the car object, which in turn called the move method on the tire, and that's why you saw the tire moving. So what actually happened? So we created the application context using this beans.xml, and in the beans.xml we told nothing but scan, do the component scan under this org.example. Simply means look all the classes in this org.example and see which are annotated with the component. So it started looking at, so it looked at the tire. Okay, so it understood that, okay, it's annotated with the component, so I have to take care of it. So it created an application context and it created an object for the tire. Okay, so then it looked at the class car. So, and it found that it needs a car object. Sorry, the car needed a tire object, right? So it created the car object by simply injecting this tire object. So it already knows what is a tire. So it injected and it created a car object. So now this is how the application context looks. It has a car object, it has a tire object. And now in your main method, after creating the application context, you can ask for whatever the bean that you want. So you can even ask for context.getBean tire.class. So you can even get the tire bean, and you can call the methods on tire. Okay. So it knows about the class, it knows about the tire. So you can simply ask the context to give those beans. So it gives those and you can work on it. Okay. So you might wonder, why are we complicating with all this stuff? Why can't you simply do something like this? Why can't you simply create a new car, or why can't you simply create a new tire? Right? So why are you actually relying on the application context? Okay, so having an application context will give us a better way to do the dependency injection. Okay, so if you see now, nowhere in our car we are doing the hard coding stuff. Okay, so nowhere we are doing uh, we are creating the objects of tire manually, right? So instead of that, we are asking it to inject. So this way we have a centralized way of maintaining the objects in our class, in our application, right? And there are a lot of benefits because of that, and we can continue that in the next class. But on overall, this is how the basic Spring application works. Okay, so you'll add the dependencies, Maven dependencies, you'll maintain the configuration, and finally you create the application context. Okay, and you start asking for the objects, and it simply gives you the objects from the application context that it has created. Okay, all right, I'll stop it here for today.